Alright, first thing I want to talk about. We saw a couple, we did one in our notes, where like the function was equal to -6, and when we did the derivative, what did we get for the derivative? 0. And you did one that at some point, I don't know, it was like 4 or something, and you did the derivative and you got 0. Why do you think both of those had a derivative of 0?
Because they were on the line, flat.
They're a constant, right? On a horizontal line. So if we think about it, anytime you have a constant function, that's just y equals a number. That's a horizontal line. What's the slope of any horizontal line?
0. Oh, well, yeah, 0.
And so the derivative, the slope of the tangent line is also 0.
What?
Now, mathematically, we can prove this. If our function is equal to a constant, then the definition of derivative is the limit as h approaches 0, f of x plus h minus f of x all over h. That's what we've been doing. What is f of x plus h?
F of x plus h?
So that means you go to your function, you replace the x with x plus h. If there isn't an x, then it's still c. Minus, what is f of x?
Also
C. C minus c over h.
Okay, so we have the limit
That's 0 c over h.
as h approaches 0 of 0, which is 0. So no matter what the constant is, we now know the derivative of any constant is 0. So if I ask you to find the derivative of a constant, you don't have to work it out now. You can just tell me it is 0.
Yeah.
Right?
Yippee.
So, woohoo! We know something.
Who's that what you're excited about? That's it.
Oh, there's more.
The rest is like saws and canes.
So
There's more.
I'm sorry. No, I was talking about homework last night. For whenever it was a constant, I just said it was 0.
Work it out.
I didn't know how to work it out. There was no variable to plug x plus h in.
I'm so disappointed. Okay, let's keep going. Let's talk about power functions. So if we have just x to the first, okay? Then if that power is 1, so if we're talking about a power function x to a power, if it's x to the first, then the line is y equals x. What's the slope of that line?
1.
1.
I bet
So,
it equals 2. Is it 2?
we think, what would the derivative of that be then? If you're drawing a tangent line, it would just be the line. So the derivative as of x is 1.
1.
Okay. This is where you can't start looking ahead. I think you're safe to look.
I'm going
Yeah,
hand
cover up the very last box on the screen.
Oh.
Do not look at that
Dude.
Oh, but I'm right-handed.
What?
one. Just put a piece of paper on it.
Dude,
Don't peek.
You
Don't
just
ruin
have to
it.
left-handed it.
Okay.
Or do this.
Let's figure out if n is 2. So, we're talking about x squared, right? So if we were going to work this out, the limit as h approaches 0 of f of x plus h, so dx plus h squared, minus f of x all over h. Just set a piece of paper on that last box. Okay, if you FOIL that, you get x squared plus 2xh plus h squared. What happens?
The h's, or the x squared and the 2x squared cancel and the h's get h'd.
The h's get h'd.
Yeah, you got a problem with it? That's not what that variable is supposed to be. On your limit? Your limit's wrong.
Don't say it.
I've also.
Think
Oh.
it, don't say it.
I already noticed the trend
So this
many times ago.
turns into 2x plus h, so that is 2x. Okay, so far, this is what we found. Okay, I'm just summarizing for a second. I'll go back to that slide in just a second. Okay, so if we have a constant, the derivative is 0. If we have x, what's the derivative?
1.
If we have x squared, what do we get for our derivative?
2x.
Okay, let's go back. So let's try if n equals 3. So this is x cubed. All right. Now, if you want your fast way of cubing this out, remember, like a long time ago, I showed you this trick, the pyramid.
She said let me talk about it.
Please, if you see the pattern, do not say it yet. I'm asking you to give everyone a chance. This is something to the 0, the first, the second, the third. So if I want x plus h cubed. Okay, these are the coefficients. So this is x cubed, it goes down. X squared, x, and there's no x's left. H's come from this direction. So this is h cubed, h squared, h, there's no more h's.
Where do we see that here?
I showed it to you at like the beginning of the year.
So
It is-
somebody didn't pay attention at the beginning. I just went.
I mean, you don't have to have it, you can multiply it all out, but we would have x plus h cubed minus x cubed over h. So we would get x cubed plus 3 x squared h plus 3 xh squared plus h cubed minus x cubed over h. What happens? You have to think about it as a negative h, and so when your h's are an odd power, the term would be negative. When it's an even power, the term would be positive. All right, so the x cubes drop.
The h would be an h. Not yet. You don't h all at once.
Question. H approaches 0 if we take an h out of everything. 3x squared plus 3xh plus h squared. If you put in 0 for your h's, you get
3x squared.
okay. So the derivative of x cubed is 3x squared.
Shoot, no.
Do not say it out loud.
Not saying it out loud.
Think about if you can predict what the derivative of x to the fourth is, and just jot it down on the margin of your paper if you think you know it.
While you're doing it, can you explain the other pyramid? Is it 1? How does it become?
Actually, you know what's funny?
So to get the next row on our pyramid,
This one.
the ones come down, then you add the consecutive digits. So 1
Okay.
plus 3 is 4, 3 plus 3 is 6,
It was the same.
3 plus 3 is 4, the 1
Okay.
comes down.
I couldn't figure out where the how.
Where the numbers.
Yes.
Okay, if this is x plus h to the fourth. So if you were using the pyramid, because do you guys really want to multiply out x plus h to the fourth?
It's okay.
No.
I'd rather not. So this would be x to the fourth, and then the powers of x go down. X cubed, x squared, x, and there's no x's left. H's come from this direction. So h to the fourth, h cubed, h squared, h, no h's left. So we're doing x plus h to the fourth minus x to the fourth over h. So that is x to the fourth plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth minus my x to the fourth. Sorry, I ran out of space there. Okay, the x's drop. What can you do with everything that's left?
H.
Take an h out. You put in 0 for all of your h's, you get,
4x cubed.
is that what you predicted?
Oh, yeah, it
Yes.
is. Oh.
Okay, so what do you think the derivative of x to the fifth would be?
5x to the
squared.
fourth.
What if I said x to the 99th?
100 x. No, 99x to the 98.
Yeah.
So I got a little confused with what was happening there.
Okay,
Can we have
So-
a number?
Where's the other?
where's the what?
The plus one. Like if it was 4x plus 1.
That's
Okay.
whenever it's the x squared minus the.
Yeah.
Something.
So you're asking how I would apply that shortcut to something with multiple terms? You basically were going to be allowed to do each one individually.
Yeah.
So, we have now found a shortcut. Did you guys ever wonder how on your homework, if you said, did I get the right answer, I could just look at it and tell you? It wasn't because I memorized the answers.
That's cheating.
It's because there is a faster way than the whole definition.
Oh,
We can use.
so like on the homework last night, the other question where it was asked, on the question where it was talking about getting like singular, where it was like find the first derivative, second, third, and then was it a coincidence that like some of the answers were just with one less x in them?
No, it's because of this property. Basically, anytime you have the derivative of an x, it turns into a constant. And when you have the derivative of a constant, it turns into zero. So that's why I was dropping the term every time.
Okay. So it's just gonna do that over and over.
If you're doing polynomials, yes. So, we now have what is called the power rule. And this is something we can now assume. So if it were me, I would probably like make nice confetti around this box because this is wonderful news for us. Yippee! If you have the derivative of x to a power, that exponent comes down as a coefficient. You keep the variable x and you subtract 1 from the power. So we can do the derivative of x to any power now. Alright, now, that being said, on the quiz that we are going to have Friday, we have spent all week doing these derivatives a long way. Do you think I'm just going to automatically let you use this?
Yes.
Yes.
No.
You are.
You can use it to check yourself.
Because you
But
love us so much.
some of your quiz questions Friday will say use the definition of derivative.
That means
If I say the definition, that's the whole limit thing. Okay? So we can't just forget that. Another thing that we have, I just put it on here really to save slides later on. We're not using it yet, but I was trying to get it on, just a couple pieces of paper. Normal line, we're going to use this definition a little bit. We've done that before. We know a tangent line touches the curve at one point, right? The derivative is the slope of the tangent line. The normal line is perpendicular to the tangent line.
Ooh.
So normal line is perpendicular to the tangent line.
Oh, we just
Wait,
do this.
how carefully do we have to flip the page? It's the
You're okay now.
Okay.
My
Secret's
secrets
out.
are revealed.
Yeah.
Yes.
So you just have to like flip in reciprocal thing. Yeah.
Okay.
For perpendicular.
If my function is x to the sixth, what is my derivative?
6x to the 5th.
Oh yeah. Already lost.
If my function is x to the 1000th, then y prime, that's another notation for derivative, would be,
1000x to 999.
aren't you glad I didn't make you do that one by hand?
We've died.
Kind of.
Pretty sure I died.
Alright, if y equals t to the fourth, then dy dt, that's another notation for derivative. would-
4t to the 3rd.
Hey, let it finish pound.
Okay, if I say d over dr of r cubed, that's another way I might say derivative of r cubed.
3r to the second.
3r to the second squared.
Okay, so do you guys feel like you can handle those? Now, we have to be careful. This is what we know, alright? We know if it's x to a power, we can do the derivative. Don't try to assume you know something you don't. If I say 1 over x squared, does that mean my derivative is 1 over 2x? No, we haven't learned that if x is on the bottom, you can just do the top over the derivative of the bottom. I haven't learned that. I cannot assume that. But use what we do know. If we can write this as x to a power, we can do the derivative.
-2.
1 over x squared is x to the -2 power. Now, if I do the derivative, so f prime of x, the exponent comes down, so -2, we keep the x. If you subtract 1,
-3.
-2 minus 1 is -3.
Oh shoot.
That one
Wait,
really
how
made
did
me
we
think.
do that?
Oh, because we
Yes.
Which one's it?
How do we get any of that?
Like, how do we get x to the negative
How do we
2?
get the negative 2 down there? The derivative.
Because the
Okay, if I
exponent
said
comes
do
down.
the derivative of x squared, what's the derivative?
2x.
The exponent comes down,
It's like a log.
so the negative 2 comes down,
Okay.
and then you subtract 1. Negative 2 minus 1 is negative 3. So same process, it just looks different because of the negative. Alright, did my rule say anything about radicals? No, but if we can write it as x to a power, we can do it. So the cube root of x squared would be x to what power?
2/3.
So the derivative f prime of x. Okay, the rule of derivative. Exponent comes down. Keep the x, and then we subtract 1. What is 2/3 minus 1?
Negative 1/3. How, like, when you look at them, at like a new problem, how fast are you at like figuring it out? Like a problem like these, are you pretty fast?
It's
Yeah.
instant. Before
Will
she
we get
even
that
says
fast?
it.
Yeah.
Yes, the answer's already in.
No, she sees the lines.
Why are you
She sees the
subtracting
pizza.
one?
She's spreading on the whole. What did you say, Grant?
Why are you subtracting one?
Okay, think about when we worked all of these out. X
Yeah.
cubed, the 3 came down, the power dropped by 1. So it's always exponent comes down, and then you subtract 1 from your power. Okay. So far, so good? So we're trying to take this nice, easy rule we have and see how far we can extend it. Alright, let's look at a problem involving normal lines. So if I want the equations of the tangent and normal lines to the curve, f of x equals x square root of x at the point 1, 1. Okay, first of all, does my rule say anything about x's being multiplied together?
No.
No. If I want a tangent line, I know that, how do I find the slope of a tangent line? We have to do the derivative. I have to do the derivative of this. But if I can't simplify it, I have to do the whole definition. So, let's think about it. We have an x times. A square root of x is the same as x to what power? If x's are being multiplied, what do you do with their exponents? So this is a 1 plus 1/2, so that's 3/2. So the derivative, make sure you're using correct notation, so when you do the derivative, it's f prime. The exponent comes down, so the 3/2 comes down. We keep the variable, we subtract 1 from the power, so 3/2 minus 1. Alright, is everybody okay with the derivative? Okay, now we need to write 2 equations of 1. So I'm going to do my tangent, my normal. To write the equation of a line, I need a point and a slope. My point is 1, 1. To get my slope, I am putting 1 into my derivative. Okay, 1 because that's the x value. Okay, a 1/2 power is the same as a square root. Square root of 1 is times 3/2. Okay, so y equals mx plus b. Subtract our 3/2, so our y-intercept is negative 1/2. So equation y equals 3/2 x minus 1/2.
So how do we find the slope? Like, what formula do we use?
We use the derivative because we know the derivative is the slope of the tangent line. And the x value of our point was 1, so we put a 1 in for the x.
Oh,
Okay, so for the normal line, I have the same point. I told you the normal line is perpendicular to the tangent line. So if the tangent line had a slope of 3/2, what's the slope of the normal line?
Negative 2/3.
flip and change the
Oh,
sign.
flip and change.
So then y equals mx plus b. Okay, 1 is like 3 over 3 plus 2 over 3 is 5 over 3. Any questions there? Let's do another one. I want the equation of the normal line. Okay. Normal, we have to first find the slope of the tangent line, right? So that we can be perpendicular. How am I going to get the slope of my tangent line?
Plug it into your derivative.
Okay. What is the derivative of x to the 4th?
4x cubed.
So, for my tangent line, slope is 4 times my x, which is -2, cubed. So my tangent line has a slope of -32. So what's the slope of my normal line?
1 over 32.
I plus m times x plus b. Okay, 16, that's like 256 over 16, plus 1 over 16 would be 257 over 16. So our normal line, 1 over 32x plus 257 over 16. So we've done lots of tangent lines before today. Normal line is essentially the same thing. You have to first get the slope of your tangent, then do opposite reciprocal. Any questions about that? All right, so what I want to do is get through
What's his proof?
a couple more derivative questions before I stop for today. I want to extend a few more things. So, like Grant mentioned earlier, most of the problems you did weren't just a plain x to the 5th or something like that. You had multiple terms, right? And you might have coefficients. So this first rule has to do with coefficients. If you have the derivative of something times your function, you can actually pull that c out in front. Okay, what that means is, for example, if I said y equals 5x cubed, when you do the derivative, all you're doing is 5 times the derivative of x cubed. What is the derivative of x cubed?
2.
And so it becomes
15x squared.
15x squared. So if you have a number times a variable, that number just gets multiplied with the derivative. Okay. Do you want me to do the proof of it? I've done a couple proofs for you. You guys okay if I skip that part? So let's try it on a few. D over dx, that means find the derivative of 3x to the 4th. So the 3 just comes, stays out in front. What's the derivative of x to the 4th?
4x cubed.
So then 3 times 4 gives me, okay. B, derivative of negative x. So this is like a negative 1x. So it's negative 1 times the derivative of x.
Because the
It's 1. Another way to think about it, this is like x to the 1st, right? if you do the power rule, the 1 comes down, x. If you subtract 1 from the power, it's now to the 0 power, right? Anything to the 0 power is 1. So you get negative 1 times 1, which is negative 1.
The day you taught us that rule, I remember going to a physical meet and we had that question and the others would have no idea what was happening when you taught us the 0.
These are like logarithms.
Yeah.
I just remember being so excited because it's so fresh in my brain.
Okay. Are we okay with those so far? So the next rule, the next thing we can know, like Grant said, sometimes we have terms added or subtracted. If you have that, you can actually do each individual derivative and then add or subtract them. So if you have f, the derivative of f plus g, you just do the derivative of f plus the derivative of g. So we're going to do the derivative of each term individually. Same thing if we're subtracting. You do the derivative of the first minus the derivative of the second. So, now we have a huge, nasty problem. Do you guys want to see the proof on this?
I believe you.
Okay. I mean, I was going to prove it in case you thought I was lying to you. But if you guys trust me, then
Okay,
we're just going to roll with it. Just a little bit of trust. I've earned a little bit over the last few years. Never told you any lies that you've discovered anyway, so we're good.
Wait a minute. What do you mean? I'm gonna graduate just to get a list out an itemized list every time she's ever
Here
lied.
are the times.
This is
Pretty
actually
much.
calculus.
Just thought I'd make your life hard.
Calculus is a made-up class, and you just trick.
derivative guy.
Yeah, just wait till we get to college and there's like nothing called it.
Yeah.
Wait, I'm sure
That woman on YouTube that I watched her do, she was actually you with a different voice.
Alright, so if I ask you to do the derivative of this entire thing, what we have now learned is that's actually very doable. If I given you that problem yesterday, you would have sat here and sobbed for the rest of the hour. But now we can do it. What is the derivative of x to the 8?
8x to the 7.
Plus, okay, I'm just going to hang on to my 12 for a second. That's coefficient. Times, what's the derivative of x to the 5th?
5x to the 4.
Now, you guys might be comfortable enough that you can go ahead and change those and make it a 60. I'm fine with that. I will start doing that, but probably not the first day. First day I'm trying to show you my steps.
What?
Okay, minus, we have a 4 times, what's the derivative of x to the 4th?
4x to the 3.
Plus 10 times, what's the derivative of x cubed?
3x squared.
Minus 6 times, what's the derivative of x?
1.
Plus, what's the derivative of 5?
0.
So we get 8x to the 7th plus 60x to the 4th minus 16x cubed plus 30x squared minus 6.
That's crazy. Is that where the h is coming from? Or like,
Yeah.
it's where the 1h is.
Okay.
Oh,
Okay. Here's what I'm going to do. I'm going to skip example 6. I'll do it first tomorrow. I'm going to do example 7, and then I really will stop for the day. Okay? All right. So here's the equation of motion. It's a position function. Find the acceleration. Okay, if I want acceleration, that's the second derivative. We have position, first derivative is velocity, second derivative is acceleration. Can I plug in my 2's at the beginning? If I plug in my 2's right now, I'm going to get a number. What's the derivative of any constant? 0. So when we have these, we cannot plug in the numbers until we are done with the derivatives. So, velocity would be the first derivative. So if I want the derivative, the 2 would stay. Derivative of t cubed,
3t squared.
5 times, what's the derivative of t squared? 2t. Plus 3 times, what's the derivative of t? Plus, what's the derivative of 4? 6t squared minus 10t plus 3. That's my velocity. So acceleration, second derivative. So we need the derivative of that answer. So we have, bless you, 6 times, what's the derivative of t squared? Minus 10 times, what's the derivative of t? Plus, what's the derivative of 3? So we get 12t minus 10 for our acceleration equation. I want the acceleration after 2 seconds, so I'm telling you that t is 2. So if you plug that in, you get 24 minus 10, or 14
Centimeters per second.
It's actually centimeters per second
Square.
Squared. Oh, because it's acceleration.
Or you can think first derivative is centimeters per second. We did it again, so it's centimeters per
Oh,
second squared.
and then cubed for jerks.
Exactly.
Jerk. Third. Okay.
All right, that is our stopping point. You can do the first chunk of problems here. Make sure you simplify